Hi, and welcome to this video on this question using a normal approximation to find each of the following probabilities. So this is actually using a normal approximation to approximate a binomial. And so when we do this, there's a couple things we have to keep in mind. We can't just put this straight into StatCrunch because we have to do some things to the binomial to make it usable with a normal approximation. So the first thing we want to do is find our mean. So we know that our sample size is 80, and then we know that our p-value is 0.5. That means our Q value is also going to be 0.5. And so when we find our mean, we're going to do N times P, or 80 times 0.5, which gives us 40. And then when we find our standard deviation, we are going to do the square root of N times P times Q. And that actually gives us the square root of 20, which unrounded is 4.4721354999,579. And the reason I leave that unrounded is because I find that I get better results with the actual StatCrunch calculator if I don't round things until the very end. So there's a couple of other things we want to keep in mind. The rules for binomials. And those are basically the rules that tell us how we write a problem. Binomials are discrete. They're not continuous, and so we have to do a couple of things to make sure that we are able to work with the binomial and use the normal approximation to find that probability. So for rules of binomials, if you have a problem that is written in the form of the probability is x less than equal to 3, what you are really finding is the probability that x is less than equal to 2. So this is really going to apply to this first problem that we're being asked to find on the probability that x is less than equal to 34. If you have a problem that is written x greater than equal to 5, the form that you write that in to be able to work it out is 1 minus the probability that x is less than equal to 4. So in other words, if in order to find 5 or bigger, you are subtracting off 4 or lower from the entire probability distribution. And then in order to find a between probability, so in other words, probability between 7 and 10, what you're going to do from there is say, we're going to do the probability that x is less than equal to 10 and subtract off the probability that x is less than equal to 6, which is your next lower number. So there's the 3 rules for binomials that we need to follow. We also have something called a correction for continuity. And we have to use this because a binomial probability distribution is discrete. It is not continuous. And so what we are trying to do with a binomial probability distribution is get as close to our value as possible. And so we compensate with this correction for continuity. So the correction for continuity actually comes in when we find our z-score. And I'll show you in just a minute how we're going to use that even though we're not finding the z-score. You are basically taking your value, whatever your value is, and in that case it would be these, the numbers that are inside our parentheses that we're being asked to find the probability of, and you're adding 0.5 to that value. So then in your actual formula, not make a mistake here. So in your actual formula, you have the z-scores, or your value minus the mean over your standard deviation. So that actually allows us then to calculate our z-score, but we're not going to do that the way we're working with these problems and going straight into StatCrunch. If you were doing it by hand, if you're doing everything by hand, you would calculate your z-score and go through the process to do that by hand. But since we are using StatCrunch, we're just going to go ahead and look at this first part, which is the probability that x is less than equal to 34. So when we work this out, what we are actually going to do from there is to do the probability that x is less than equal to 34.5. Because that gets in our correction for continuity. So then when we go to StatCrunch, what we're going to put into the normal calculator is this x is less than equal to 34.5. We're going to put in our mean of 40. We're going to put in our standard deviation of 4.472135. So I'm going to flip over to StatCrunch, to my normal calculator, and I'm going to put in that mean of 40, that standard deviation of 4.472135, 4,999,579. We're doing a less than equal to 34.5, and I'm getting out a 0.1094. Okay, a 0.1094. So that is probability of the first piece. Then we are going to move on to part B, which asks us to do probability of 39 less than equal to x less than equal to 49. So this is a between probability. We're going to rewrite this as probability that x is less than equal to 49. So there's that piece right there. Minus the probability that x is less than equal to 38. So that is the next lowest from the number that we started with. So then we go one step further here. We have to remember that correction for continuity. X is less than equal to 49.5 minus the probability that x is less than equal 38.5. And these are the pieces I'm going to put into StatCrunch. So I'm doing 49.5, and I'm getting 0.98317242. And then I'm doing 38.5, and I'm getting 0.3686692. I am going to subtract those two. And it looks like I'm getting 0.6145 for the answer on that piece. And then the last part of this, the probability that x is greater than equal to 37, means I'm going to do this formula, and that's going to be 1 minus the probability that x is less than equal to 36, or 1 minus the probability that x is less than equal to 36.5. That's the piece I'm putting into StatCrunch. So 1 minus 0.21693326. And I'm going to go over to the calculator and I'm going to do 1 minus 0.269, sorry, 2169, 3326, and I'm getting 0.7831. So I hope this was helpful for you in terms of how to use a normal approximation to find a binomial probability. I know this is a little bit more tricky than just the regular normal probabilities that we put straight into StatCrunch. The binomials are probably the most tricky that we do, simply because we have to remember to put them in the proper form, and we have to remember that correction for continuity. And so after that, after we've done that work by finding our mean, our standard deviation, our rules for binomials, and our correction for continuity, then we can go straight to the normal calculator on StatCrunch and we can put this in and get our answer. So I hope this was helpful. If you have any questions, please feel free to email me and let me know.